Hi there, and welcome to this chemistry lesson where we will be looking at the formulas for ionic compounds. Okay, so what am I talking about? Ionic compounds mean I have two ions in an anion. Okay, well, let me write it like this: a cation and an anion creating a compound. Now, the cation has a positive charge, the anion has a negative charge, and because of this, these opposite charges, they have a strong attractive force between them, therefore creating a molecule. Okay, so with that in mind, let's go ahead. In the first place, what do we need to know? Well, when it comes to the formula for an ionic compound, we always start with the cation first, okay? And then we have the number of cations that we need as a little subscript, okay? And then we write our anion and the number of anions we need as a subscript as well. Okay, now what do I mean about the number of cations and number of anions I need as a subscript? Well, the thing is that the compound in the end must have a neutral charge. Okay, so it's very easy if my cation has, for example, I've looked at this so many times. We have sodium and chlorine. Sodium has a positive charge, chlorine has a negative charge, so this is very easy. This is sodium chloride, just like that, okay? But what if my cation, and for cation, can't you see, that's carbon, okay, so let me just use A. What if my first, my cation, now A seems to be the anion, so let me use B, okay? So let me just use C. What if my cation has two positive charge and my anion only has a 1 negative charge? Then you will notice that now I need two anions to satisfy the two positive charges, okay, so that in the end I have a neutral charge. So I will have two of these to produce a neutral charge in the end. Okay, so in step 2, what we need to do, and for me, since I'm a math teacher as well, it just makes sense to find the LCM, the lowest common multiple of the charges. Okay, and let's call that LCM just L. Okay, then N, the number of cations I need, will be the lowest common multiple divided by the cation charge, okay, and M will be the lowest common multiple divided by the anion's charge. Okay, so and then I've got my formula. Okay, I think the best way to proceed from here is to actually just go and do some examples. Okay, before we get there though, is when it comes to the transition metals, okay, that's something, let's not call it 3, that's an additional note. The transition metals, very important. Transition metals may have different charges at different times. So for example, zinc may have a 2 positive charge, but it may also have a 1 positive charge or a 3 positive charge. Okay, so transition metals have different charges. They're always positive, but they might be different. They might have a different charge. So just to show you on the periodic table, these are the transition metals. Okay, the transition metals are all these ones, so their charges has to be given to you. If we have to write the formula, they have to tell us what the charge is, and in the example we'll see how they give those charges. Okay, so but let's get started with naming or getting the formulas for these compounds right here. Okay, so we've got magnesium carbonate. Okay, so we know magnesium. Okay, magnesium is Mg. Carbonate. Okay, you might remember that in our periodic table, if we go there, carbon formed part of the T, is part of the T, which means he had 3 oxygens. Okay, and this was the -3 charge, and this was the -2 charge. So carbonate is CO3 with a 2 negative charge. Okay, now magnesium, let's go see what charge does magnesium have. Okay, all the elements in the first group will have a 1 positive charge because they give away, they've got 1 valence electron. When they give that away, they have 1 excess protons. All in these will have a 2 negative charge. Okay, positive charge, sorry, because they give away 2 electrons. So this one will have a 2 positive charge. Now here we can see, oh great days, because here the 2 charges just cancel one another out. So, and I should write it like this, so the magnesium ion and the carbonate ion produces magnesium carbonate. Okay, that's magnesium carbonate. Okay, here we go. Aluminium hydroxide. Okay, aluminium, we go and look at aluminium. Here's aluminium. Okay, aluminium is in the 1, 2, 3 in the 3rd column, which means he's got 3 electrons that he wants to give away, giving him aluminium a 3 positive charge. Hydroxide is one of those that I now regret not showing you as a special one. It really comes up a lot, but you will use it so often that you won't have a problem remembering it. Okay, we already know that oxygen has a 2 negative charge. Okay, because he's in the 6th group, he wants 2 extra electrons, so he gets the 2 and he's got 2 negative. Hydrogen shares his valence electron, giving him a positive charge. So in the end, the 2 negative and the 1 positive gives this an overall charge of negative. So hydroxide, and sorry I didn't say that, hydro always represents hydrogen and oxide is oxygen. And you might remember from the Hill system that when we write our element, we always start with carbon. Sorry, we start with carbon and then we go to hydrogen and the rest goes alphabetically. This is one of the exceptions. Okay, this is hydroxide and it's used so often, and it is a very important anion, and so please do take note of this, that it is important. So here we can see, well, we've got 3 aluminiums. We've got an aluminium with 3 positive charge. We've got a hydroxide with a 1 negative charge. So we need 3 of these to satisfy our condition. So we have aluminium. Okay, we only need 1 of them, so there's no footnote necessary. Subscript footnote. Okay, and then we have hydroxide, and notice how I put hydroxide in brackets and give it its subscript to tell me that in the molecule, in this molecule, I will have an aluminium, 1 aluminium ion, and I will have 3 hydroxide ions. Okay, iron 3 chloride. What is this 3 all about? Well, this is exactly what I meant here. With the transition metals, they have to give us the charges. Okay, iron may have different charges at different times. Iron 3 means we are working with an ion that has a charge of 3. So if I do that, I've got iron 3. Okay, it's my cation. plus chloride. Chloride is just chlorine, so Cl. Chlorine is in the group 8, which means he needs one more electron, giving him a 1 negative charge. Okay, and so here we see, okay, similar to the previous one, we have iron, we have one iron, but we are going to need 3 chlorines. Okay, 3 chlorines, which means chlorine gets a 3. In this case, I don't need a bracket. I only need the bracket when I'm working with polyatomic ions, with more than one polyatomic ions. Okay, so don't worry about a bracket with chlorine here. Okay, the next one we have sodium bicarbonate. Okay, now sodium is in group 1. We've used that one so many times, I'm sure. You know sodium has a 1 positive charge. Bicarbonate. Can you remember what bicarbonate is? Well, the bi tells me I've got a hydrogen. Okay, a hydrogen. The carbonate, okay, if we go to carbonate, we know that that is a polyatomic ion. Carbon is there. Carbonate is carbon has 3 oxygens when it ends on an ATE. Okay, so carbonate, and it has a charge of -3, -2. So it has carbonate has a charge of -2, but because we're adding a hydrogen to it, we're adding 1 positive to it, so the -2 becomes -1. Okay, so this gives me sodium, and here you can see again we've got the same charges on both, so they just cancel out. So we have sodium bicarbonate. There we go, sodium bicarbonate. Excellent. Let's go to the next one. Ammonium phosphate. So we've got the ammonium atom, NH4. Very important to know this one. Ammonium is NH4. Phosphate, okay, phosphate, let's have a look. The 8 tells me I'm working with the base. Okay, phosphate is here. You might recall phosphate was in the 4. There's the 4, so he's got 4 oxygens, and since he's the first one in the 4, he has the 3 negative charge. So phosphate is PO4 oxygens with a 3 negative charge. And here again we see, okay, this time I have a problem because I've got I don't have enough of these ones, and I forgot to add my 3 here. Sorry, I needed 3 chlorines. Okay, here I need 3 ammoniums to satisfy the charges. So now I've got sorry, I don't write it like that. It is ammonium in brackets, since we need to show that the whole ammonium polyatomic ion must get 3 as a subscript, and phosphate like that. Excellent. We only need one of them because he has the one with the excess charges. Okay, let's come to tin phosphate. Okay, so tin, again, it is a transition metal. Okay, tin phosphate is SN. Okay, where is it? Tin. Okay, a post transition. Okay, but in this case as well, we know it's in group 4, and yet it so it does have a 4 charge. But tin can also have more than one type of charge. So tin 4 is telling me that SN must have a 4 positive charge. Okay, sulfate. Okay, sulfate, let's go find sulfate in here. Here is the 4, so there's the T, here is the 4. Sulfate therefore has 4 oxygens, and sulfate is the one just after phosphate, so where phosphate had a 3 negative, sulfate will have a 2 negative. So SO4, 2 negative charge. Okay, and here it is very important for you to note that what I said before. Here we have now different charges, so we must get the lowest common multiple between 4 and 2. The lowest common multiple between 4 and 2 is 4. Okay, so we have Sn and we have SO4, and now we need to see and sorry, that N doesn't work nicely there. Okay, so now we need to know how many of these do we need. Well, we know this one is an excess, so we might need more of these, but we might have to, well, let me show you. Okay, if we take this 4 and now we take the LCM, the lowest common multiple, and divide it with the cation's charge. My lowest common multiple is 4. If I divide it with 4, I just get 1. So tin, we don't need more than 1 tin. And you could have done it without this calculation. You could have seen, well, I just need 2 of these to satisfy the 4. Okay, so so you could have done it like that, but just to follow the system to give you an opportunity to see it in action. Okay, now for sulfate ions subscript, how many of them do we need? Well, my LCM is 4, my anion's charge is 2. Okay, so when I divide, I get 2, which means I need 2 of these. Okay, 1 of these, which I don't write, and 2 of those. Okay, and then the final one, potassium perchlorate. Okay, so we see the per and we see the 8. Okay, well, let's start with potassium. I'm so excited to get to the perchlorate. Okay, let's start with potassium. Is in group 1, which gives him a 1 positive charge. So potassium has got a 1 positive charge, and perchlorate is perchlorate. Chlorate is here. Chlorate forms part of the 3. Okay, so chlorate has 3 in its base, but the per in front suggested 3 oxygens in its base. Let me just correct myself. The per tells me I've got another oxygen. An oxygen was added, then we add a per to the chlorate. So in other words, this one is ClO4, chlorine 4. Okay, so, and chlorine, phosphate had 3 negative, so this was 2 negative, so chlorate has a 1 negative charge. So this is a 1 negative charge, and now potassium perchlorate, since we see, okay, I've got a single charge there, a single charge there, so those 2 charges just add up to give me potassium chlorate. And that's it. This was a lot of fun. I really enjoyed doing this because it's simple and the systems work very well. I didn't get to show you an example of using, I was hoping there would be an example among these ones. I just assumed there would be. Okay, an example where finding the LCM might be a little bit more difficult, but I'll quickly think up one. Okay, I have a nice one. Okay, it's aluminium, aluminum, oh, aluminium, sulfite. Okay, great. Aluminium, we've already seen aluminium has a 3 positive charge, okay, because he's in group 3. Sulfite, okay, so if we go and look at sulfur, sulfur was in the 4, which means he had 4 oxygens in his base, but that would be sulfate. Sulfite means I've got 1 less oxygen, so this is SO3. Sulfate had a 2 negative charge, and sulfite will have a T2 negative charge. Okay, so here we have an excellent one where we have to find the LCM. So we see that the LCM, the lowest common multiple for these 2, is 6. Okay, so to find the number of aluminiums that I need to have a total charge of 6, 6 positives, and then I'll have 6 negatives, that would mean I need 2 aluminiums. Okay, so basically all I did was to take this divided by the 3 to give me my 2 aluminiums that I need. So I need 2 aluminiums. Okay, and for my sulfite, I see that I have a 2 negative charge. If I needed my 6, okay, the lowest common multiple, then I would have to multiply with 3. Okay, so I could have also just said that I take the 6 divided by my charge, which gives me 3. And that I have to put in brackets since I'm working with a polyatomic ion, and that gives me this. Okay, and again I just need to change, I keep forgetting to do this, just to show I need 2 of these ions, and I'm going to need 3 of these ions, and I'm going to need 2 of those ions. Okay, and this becomes important a little bit later as well when I'm going to show you how to balance chemical equations. Then this is going to be helpful. Thank you very much for watching. I hope you enjoyed learning how to write the formula for ionic compounds. As you can see, it's not difficult, and you are not going to have a problem if you get this. Well done. See you in the next lesson.